This is not an unfamiliar sight to most of us, whether we are students at a university, employees at a corporate, or just townfolk enjoying an evening stroll in a park. Plastics, disposables, and similar litter tend to accumulate in public spaces and venues that host large gatherings. A lot of work goes behind the scenes in order to keep these places clean. Municipalities, businesses, and institutions employ a large number of cleaning staff to this effect. Currently, a majority of the work is done manually or using basic equipment.
The cleaning industry is estimated to be worth over $90 billion. Like many sectors, this labor-intensive industry is facing major staffing issues. Reports and our research indicate many companies are losing revenue as they do not have the labor capacity to meet demand. Several others are forced to hire from staff and third parties on short notice and so losing their margins. Open and public spaces can be large and spread out, making the manual cleaning of this space time-intensive, tedious, and physically tiring. Unlike the cleaning of complex environments or indoor spaces, large areas require simple, repetitive, and mundane labor. Having to allocate large amount of human hours to the simple cleaning of open spaces is loss of productivity to the company. We believe that there is a space in the market for new innovation.
I don't know of any automation that's a part of it currently. I think that could be a great niche and an area where autonomy would be very successful.
In outdoor spaces where there's lots of area with absolutely no obstacles, and if your entire area is known, then one can easily use kind of like off-the-shelf standard planning algorithms and apply some form of adaptations if for some reason there's humans walking by. So I think that these type of applications are really interesting for autonomy at this point.
With that, we would like to introduce to you the SauberBOT. Inspired by the German word for clean or sauber, our product makes the cleaning of outdoor spaces hassle-free, efficient, and fast.
Equipped with the latest technology, the robot uses AI and state-of-the-art algorithms to operate autonomously, while the human workforce can be more effectively utilized on the complex aspects of cleaning that demands attention. Before designing our system, we reached out to industry experts in an attempt to better understand the nuances of the task. We understood that in order to be successful in the industry, it is important to be cognizant of the fact that different contracts or locations could require varied levels of cleaning and involve changing environments. So a product that is very specific would not work.
We got to the drawing board and began to outline our key design philosophies: modularity, simplicity, and safety. We wanted to build something whose functional components could be decoupled, allowing the customer to choose what they need and pay only for what features they need. We also wanted to be able to upgrade existing models if the customer wanted to, without having to reinvest money for a brand new system. The modularity would make our system platform independent, allowing the customer to integrate autonomy to existing mobile platforms or selectively upgrade features. We built a functional prototype that demonstrates a proof of concept for park environments. It demonstrates efficiency, safety, and speed in arbitrarily chosen park settings. We offer several features in our system. The robot will be autonomous. Once initialized, it will navigate within a geofenced region and collect expected types of litter seamlessly. It will operate intelligently. It is equipped with a stereo camera that feeds into an AI system that will identify litter which the robot is capable of collecting. It will be safe. It boasts an industrial-grade SICK LiDAR that identifies obstacles in the path with low latency and high precision, ensuring the robot does not collide with them. This data is fed to our planning algorithms that would allow the robot to effectively avoid them. Safety of the robot and people around it is paramount, and any potential problems would stop the robot and notify the supervisor for human attention.
With SauberBOT, we estimate that we can make outdoor cleaning 3 times faster and increase coverage efficiency to 95%. Furthermore, we can free up hours of labor time to be better utilized in other areas, helping companies increase client satisfaction and meet demand. We intend to sell our product to businesses and corporations. Our modular design makes the SauberBOT economical and versatile. The option to incrementally upgrade allows smaller companies to build their confidence with the product and upgrade as they need to without a huge upfront investment. The customizability allows us to cater to the specific demands of large companies and tailor our product to their needs. Going forward, we intend to test and collect more data by deploying the robot in the areas around our university. We have several design ideas in the pipeline to make the robot more robust to harsh climate and different terrains. With the intelligent identification of the waste being collected, we also hope to use the data to identify patterns in zones and types of waste accumulation, using which we can combat littering. We are also looking into ways to incorporate recycling and waste segregation at the source using our camera system. Our innovative product is poised to revolutionize the cleaning industry.
Make the world a Sauber place with SauberBOT.